السلام عليكم جميعا. يسعدني ويشرفني أن نلتقي بحضرتكم في محاضرة أخرى في برنامجنا الجيست سبيكر سيمينار. هذا البرنامج اللي ينطلق من شعبة البحث والتطوير، والذي يهدف إلى تطوير وإبقاء تدريسي الجامعة التكنولوجية مع المستوى العالي للبحوث في دول العالم المختلفة، وكذلك ينمي عملية الاطلاع على مستجدات الحركة العلمية. ضيفنا لهذا اليوم دكتور ميثم، هو خريج الجامعة التكنولوجية فيما يخص شهادة البكالوريوس، وتم التواصل معه عبر دكتور سليم خليفة من قسم الهندسة السيطرة والنظم. الشكر الجزيل لكل من ساهم بإعداد هذه المحاضرة. دكتور ميثم، أترك المحاضرة لحضرتك لتعرفنا قليلا عن نفسك، ومن ثم الانتقال إلى مضمون محاضرة اليوم.
مشكور دكتور أمجد. السلام عليكم ورحمة الله. طبعا اسمحوا لي راح أحكي بالإنجليزي لأنه ما راح أقدر أوفق يعني بين عربي وإنجليزي أحول على التيرمز. Anyway, so as for today, I'll be presenting an introductory lecture for Internet of Things. So the title, as you can see, is Introduction to the Internet of Things as Technology and its Application. I am currently working as assistant professor at the Uttar University in Malaysia, and I have graduated from my BSc. Actually, I graduated from UOT, from the Department of Control and Systems Engineering, and then I have traveled to the UK and studied their higher diploma in IT in Middlesex University in London itself. And after that, I traveled to Malaysia, and I carried on with my master's degree in information technology, and then back to my original field, which is electrical and electronics, in the same university. In addition to my main qualifications, I have actually got some professional, let's call it, of specialty qualifications from different universities or some companies. For example, here you can see I'm specialized in Internet of Things from the University of California, Irvine, in the USA. And then I am certified as well as professional educator or innovative educator by Microsoft USA. Okay, so let's start talking about IoT, and we can define IoT. Actually, we can't find the definition on internet, but everyone will be saying different words about it. But anyway, at the end of the day, you will find that all of them, they are going to tell the same context or the same concept, but using different words. So here, for example, I would say Internet of Things is a concept of connecting objects with other objects and or with services via the internet. So first, we have to know what are these objects, what kind of objects we are connecting. And when we say internet, are we talking about google.com, yahoo.com, or what's the meaning? Because nowadays, when we say internet, the first thing comes to your mind, Google, right? So we have to understand what's the meaning of Internet of Things, and what's wrong with the current internet, so that we have to come up with Internet of Things. The concept or the naming of Internet of Things was firstly introduced by a British technology pioneer named Kevin Ashton somewhere in 1999. However, that does not mean Internet of Things came up on his hand. In fact, he is the one who introduced the term IoT. But actually, before that, there were some applications and some projects related to IoT. But at that time, it was not named as IoT. Yeah. But anyway, this guy, Kevin Ashton, in fact, he has some really interesting publications in terms of books and papers So whoever wants to get good foundation about IoT, then I would recommend that you go seek for his publications. Okay, and the best way to study anything is basically to understand first the terminology of why it's called like that. Yeah. So here we are trying to study Internet of Things. So there are two terms here. Before we understand the whole term as one term, we have to understand the subterms, which are Internet, and then another term is things. So Internet is itself, it's subdivided into two parts. Inter means between. Net is just a short for network. So here, just saying like network of networks. This is the translation of it. Sometimes it's called as the global network. Yeah, but let's focus on the previous naming, which is network of networks, and keep this on mind. The other part is things. What are these things? So when we say internet nowadays, we're just talking about internet, we will think about connecting our PC to a server, maybe somewhere on the internet side. And then maybe from there, I forward my messages. Those will be sent to other computers, something like that. But here we are saying Internet of Things. So what are these things? We have to understand the word things. There must be something different about it. So objects, actually, things are objects with interesting data called as IoT devices. Yeah. What's the meaning object with interesting data? Well, that depends on the application we are working on. If let's say, if we are working on healthcare, yeah, to monitor the health of old people, let's say, or some sick people. So here, what kind of data we are interested in to collect from that person? Then these are the interesting data. So the human being or the patient will be that object we are interested in to collect the data from. And these objects, you can see, it can be seriously anything. Anything. Can be human, can be a phone, can be a car, can be a dog, can be a light, can be anything. Excuse me. So if we are, for example, we want to create an application for positioning stolen cars, then our object will be the car itself. What kind of interesting data we are seeking for? The position, the coordinate, the GPS coordinates, right? The same if we are looking for lost dogs or lost pets, then same thing. There is the object will be the dog, and the data we are interested in are the position coordinates, and so on. Yeah. I will come to give you actually quite a long list of examples through the lecture, but whatever list of examples we are going to talk about, we will not be able to cover all the examples available around the world. And you will see why, actually, because it's very wide open area. IoT areas. You know, when you study papers or publications, let's call them publications around the internet, you will find some people say, okay, I'm going to do something related to, or some application related to home, some other related to transport, community, and so on. Maybe if you study some surveys about IoT, then they will tell you these are the areas: home, transport, community, national, industries, and so on. Yeah. So maybe they will list down up to 10 areas. But take it from me, it's really unlimited areas. There are unlimited areas for IoT. IoT, in fact, can be implemented everywhere. As you will see in our examples, these applications, actually, they are just like just very few out of millions maybe out there. Yeah. So here, when we say, for example, home, the IoT area at home. Home what? Home security we want to focus on, or we are interested in home health, for example, or the entertainment side, inside the house, or utilities and appliances. So which application you want to go to? All of them are under home. And sure, there are others as well we can do inside the home. When you move to transport, what you want to do? You want to trace your ambulance cars, where are they? You want to organize your traffic or logistics or highway and so on. Yeah. But again, in addition to these, you will find maybe tens or hundreds of other applications beside what I listed here. So let's jump directly to the examples of real examples, real projects. Those have been implemented either here in Malaysia under my supervision or under other people supervision. Like this, for example, this project, University Attendance System. The university have implanted some RFID detectors in classes. So every class will have some detector, most probably nearby the door. And then there is a central attendance system at the Ministry of Education or Ministry of Higher Education. So this system was created actually to trace how much percent the attendance of the students per year or per course. Why is that? Because at some point of time, they discover that there are some students, international students, they are registering in some university as students, but actually they are doing some black market jobs in Malaysia. And they are not really attending the classes. They are just paying the fees, but they are not attending. So to solve that, they created this system. So anyway, the students will attend the classes. That will be detected by our sensors here. Then these sensors, they will forward the messages to the internet. And from the internet, the data will be retrieved by the central attendance system at the ministry, and finally make a report for the admins. So this is one of the applications. This is just one of the applications. But similarly, maybe the similar, structure you can use by placing, let's say, these sensors at the parking to detect the staff when they come in, when they go out, for example. Yeah. So it's the same concept here. Instead of students, it will be staff, and the place where we set these sensors will be at the parking lot. Those sensors will detect the staff IDs or RFIDs, and then forward the data to the internet through specific protocols. And then after that, they will be forwarded to maybe our management, the university management. And they will see if there is someone late for the job, or what they call, maybe they don't even attend the job. Yeah. Another field, healthcare. So healthcare, here we have patients, and these patients, they really need to be monitored in terms of maybe blood pressure, heartbeat, and maybe some other things they want to detect. So they will be wearing some devices, can be just like a watch, wristband watch, or can be stack patches nearby the heart. Yeah. And then these sensors, they will be detecting or reading the data from the body and forwarding them to the internet through specific protocols related for IoT, specifically for IoT. And then those data will be forwarded to the doctors of the patient. At the same time, it will be sent maybe to a health center so that they will analyze the data and send some reports to the doctors, saying maybe to take action, or maybe just for the records, to keep it for records. Again, this is just one example in healthcare, but there are tons of them there. Smart homes. Nowadays, this smart home is really bombing out. I don't know why. Wherever we go, actually, we can see people installing these smart home things. Okay, one example here. When you leave your house morning, what will you do? First, you will shut down everything, right? Shut down the fan, shut down the light and everything, aircon, and then leave, right? Which will take from you maybe some 1 minute or about that. They said, okay, why don't we create some system? That system will be installed near the main power switch, and it will control the electrical appliances based on some signals sent by another device placed in the car. So when the person is leaving the house and that is detected by the onboard device, then the house device or in-house device will start shutting down the appliances one by one. So no need for us to shut down these manually. Well, I find it's for lazy people, but anyway, but it's working. Anyway, a lot of people actually installing this. And the other way around as well. When the house is already empty and no one is there, and now I'm leaving my office towards my house, then my onboard device will send data to the in-house device telling that I am on my way, so turn on the appliances. So maybe when we reach around 10 minutes away from the house, the in-house device will turn on the aircon, so it will prepare the the cool air for you, maybe lights, maybe the garage door, and so on. So there are many appliances actually we can control, water heater, rice cooker, and so on. Okay, my smart room. This is one of the applications that my students actually have done before. It's a simple application for the university hostel. So they said like every student has his or her own room in the hostel. And sometimes because they are rushing toward the lecture or they are late for anything, then they might forget to shut down the fan or lock the door or the lights. So they said, basically, let's create some kind of device that will control these appliances wherever we are. As long as we have internet connection, then we can control these appliances from far away. And it's done because with very simple ingredients or components. Yeah, it's already done. They just use some third-party actually application here, and after that they created some simple circuit. It's they are using actually Atmeg. This is actually not a Q. This is written wrongly. It's Atmega 328 microcontroller, or what's called Arduino. Yeah, I'm sure many of you have heard of. And then they set this device near the main power switch of the room. And they do the proper wiring, so they could control the speed of the fan, whether it's on or off, or even the speed of it. I mean, whether it's level 1, 2, 3. The door, whether it's locked or not, we can control it. And the brightness of the light as well, whether we want to save electricity or something. Yeah. So here in the application, there are some modes, ready modes, like for example, sleeping mode. If they click on sleep, what they want to do in sleep while sleeping, basically they want to shut down the light, plug the door, turn on the fan, right? So they don't need to press these three as well buttons here to control. They will just select sleeping. Then that procedure will be done automatically. Or any other procedure, you can program it simply. Smart shopping. Okay, this is real application in Korea. It's, in Korea, actually, people using not only Korea actually, but many countries, but specifically Korea, their number is big and huge, and then they don't really use cars because it's expensive in terms of petrol, parking, and so on. So majority of people, they tend to use public transport, like buses or trains. So while they are waiting for their train or bus, there are some screens placed at the bus station or train station showing products such as grocery products or whatever products they have. So these people, while they are waiting for the train or the bus, they will start scanning the QR codes of the products and the quantity they key in, how much quantity they need. So that list of items will be sent to the grocery shop. Until they reach to home, the supermarket will be sending or delivering these items to the house. Smart agriculture. This is another application one of my students have done lately. I think just before we get COVID-19. Yeah, we have like nowadays the farms, they have sensors placed at specific places with specific distance. Those must be measured somehow. And then these sensors, they will just check or detect whether the soil is dry or wet, whether humidity, fertilizer, whether it's enough or not, the ground, whether it's acidic or salty, or how is it. So all these information will be forwarded to the farmer or farm manager. At the same time, it will be sent, some signal with a specific request will be sent to a drone. This drone basically has a tank, one for water and another tank for fertilizer. And let's say this sensor here send the request. So its position will be sent beside the request or the status. Based on that, the agriculture drone will travel by itself. No one will run it. By itself, it will turn on and travel to that point and start dropping the fertilizer or the water. So this one of the applications actually done last 1 year and a half about. Nowadays as well, this one is becoming very famous, smart hydroponic farming. I'm not really very knowledgeable about it, but my students, they studied about and they said, okay, why don't we just do it? We control actually the fluid for this, or the, what they call it, the water and the fertilizer for this hydroponic. So when I see what is it, actually these are just empty pipes, and they have, these pipes, they have some liquid which contains fertilizer, some minerals, and water for sure. There is no soil actually here. There is no soil at all. So what they said, all we need to do is we program our device here, or our application, sorry, and then that application will control the water pump and the lighting for these racks. And let's say there is low water in this place, or there is low salt in the water. That will be reported, and then from here manually we can control to turn on the salt or the fertilizer. We can choose what we want. So you see here we can control actually the base liquid flow, the fertilizer amount, the light brightness, whether it's very strong or lighter, the air temperature, and its humidity. You see, I am not related. I am not a person who is related to farming. You know, I never did farming actually in my life. But you see, even though I am not related, I'm still productive in terms of controlling these things. Why? Because the job I'm doing is not related to the plant itself, is related to the flow, or some water flow, or some liquid flow. Well, that can be controlled by water pump, and the water pump connected to some microcontroller, and then I connect to internet. From here, it's my field, yeah? But I am not really related to the planting. So I can replace this plant with anything. You yourself, you can do so. You can replace this plant with anything. Just you need to proper programming for it, and there you go. Another project of mine, my students actually, not mine, my students, is poisonous gas leakage detection in laboratories. Actually, this project was triggered because of an incident that happened in University Technology Petronas, where I worked before. There were some students, what they call postgraduate students. He fainted in the lab because there was some poisonous gas leakage, but he does not feel it because the gas has no smell. So what happened is, luckily, his friend was on the way to the lab. He found him, then he applied the HSE procedure, then called for help. So anyway, when I heard about this incident, immediately the idea came to my mind. So I asked my students to do such thing. Again, it's the same micro. You can see most of the time I'm using Atmega 328 microcontroller or Arduino, but it's not the only one we can use. Actually, there are many others, but this is very cheap, and well, you know, for students we have very limited resources, right? So anyway, here we connected this microcontroller into different sets of gas sensors. One to control the LPG, liquefied petroleum gas, and the other was, I think, ammonia it was, or something, yeah. So these we connected to this Atmeg, and then after that, some reading will be sent to our control room dashboard, where they can see how much percent of the gas is being emitted, or what's the amount of gas being emitted actually currently, and at the same time, it's recording the history of the emission for each gas. Yeah. Okay, so you can see all these applications I have talked about. I don't know how many. They were around 10 or something. I did not really cover anything compared to the world. The world is really running very wild in this field. Later, I will tell you about something maybe you can watch related to this matter. So anyway, all these communications are meant to be done between things. And we said nowadays, the number of things is increasing. So there must be some kind of new protocols to be implemented. Yeah. So first, let's see what IoT connectivity models are, and then we see what kind of technology is supposed to be there. So here, IoT actually uses 4 models of connectivity, as you can see here. So let's look to one by one. Device-to-device communication, where currently we are using this, I mean, like a Bluetooth or Zigbee between devices, right? Like, for example, let's look to this side, yeah? I'm wearing, for example, my watch, and that watch connects to my phone. So while I'm walking, it will detect my heartbeat and everything. Then it will send the records to the phone where the data will be kept. So all my data will be kept here. When I go to visit my doctor and he asks me, what did you do? How did you walk or not? How was your heartbeat? Well, for me as a human, I don't really know whether my heartbeat is increased or decreased and when. So all I have to do, I go to my phone, I show to my doctor, these are my records. Then he will look and see whether good or not, or need some action. Yeah. So anyway, so this device-by-device communication, can be any of the communications, the legacy communications. There is nothing new actually about it. There is another one called device to cloud communication model. Now we are connecting our devices, our things, to cloud, to a cloud. So here, for example, some sensor or data source. By the way, here, not necessarily a sensor, can be a data source, something generate data by itself. Yeah. That sensor or the data source will upload data via Wi-Fi, let's say, to the cloud. And then from there, these data can be pushed to devices automatically. When we say pushing data, it means automatically done, or by request, on-demand user. So the user will send a query for data and receiving those data to his phone or laptop. So anyway, so this kind of communication we call device to cloud. And then there is device to gateway model. Okay. This one, we need actually something new about it. Why is that? Because even though we have at home gateways, maybe most of you have internet at home, so your laptops will be connecting to some central device we call router, and that router acts as the gateway to the internet. So this gateway will not be sufficient for Internet of Things. Why? Because the number of the things will be very much more than nowadays. Like that router in your house, maybe it will allow you to connect 4 or 8 devices maximum. It cannot allow you to connect more than that. But the new model must allow as many devices as it could be. Yeah. So this centralized device can be a computer, can be the phone itself. Your phone itself can be a gateway to other devices. Yeah. Let's say the example just now I told you, my watch connected to the phone. So my watch will send data to the phone, and the phone acts as the gateway to the cloud. And maybe there are tens of sensors around me. So my device will act as the gateway to forward these data to the cloud. So this is the same example I mentioned just now. The connection between the gateway and the sensors can be IP or non-IP communication, whether it's normal IP communication, Wi-Fi, or it can be Bluetooth communication, yeah, non-IPs. But the communication between the gateway and the internet or the cloud must be internet protocol, some IP. Why? Because my phone will be seen by the global network. The last side is called, or the last model, sorry, not side. The last model called back-end data sharing model. This one as well, in IoT, it was introduced, or just before IoT. At that time, they call it web services, yeah? So now with IoT, we have, let's say, one IoT device here, another one here, and there is a service, some service provided by this server connected to a cloud as well, and a group of services connected to another cloud. And then there is, they are connected, these clouds, via the internet. So here, what's happening is, when I'm, let's say, standing here, asking for a specific service from this cloud, but this cloud does not provide that service, then the cloud itself will communicate with another cloud over the internet to get the service for me. When the server replies back, that cloud will communicate at the back end with my cloud and then forward to me the service. By the way, it's a common question. Many people asked before about this. What's the difference between cloud and internet? Actually, cloud itself is the service that is running over the internet. But the internet is the network that connects these clouds, that connects these networks. Remember I said internet is the network of networks at the beginning. So these are the small networks. These are the small networks. Another small network, another small network. These networks are connected via the internet. So internet is the connectivity. Clouds are the services. Yeah. If we look to the DIKW pyramid, you can see here, there's data. Above data, there is information, then knowledge, then wisdom. In other words, data is a very abstract set of digits, let's say. Yeah. So these data are being collected by the IoT devices. Like, for example, I'm collecting the temperature of some patient. So if you collect the temperature from 10 patients, at the end of the day, you will get an array of numbers, right? Each number is temperature of a different patient, right? So this one, we call it data. But then after that, how can I make the use of the data so that I can produce an information? The information is based on these data. I can say most of the people are cured. They don't have COVID-19. They don't have fever, let's say. Yeah. So I can say 100% of the people are safe based on the data. But data alone, just as numbers, make no sense, right? IoT, where IoT reside in this? IoT reside in collecting data and partially making information out of those data, partially. But with the help of machine learning, nowadays, we can create full set of information and knowledge. Yeah. So I will not really cover the up ones, but I can just tell you, machine learning and IoT can create information. Machine learning with deep learning, they can go upper here. Yeah. So all together, we call it big data. All of this, we call it big data. The big data field is not about just analyzing the data and how can I make use of the data. Making use is just part, like here, what I said. How can I make use of the data by making information and then change the information into knowledge and then into wisdom? So these are just parts. But collecting the data itself is part of the big data. How can I collect the data? Where can I store them? Yeah, because they are a huge amount of data. If, let's say, as we are now in a COVID-19 pandemic, so maybe we want to collect data about all the citizens, let's say in Baghdad. Yeah, where shall we save all their data? That must be concern of big data. How can we make backup for these data? How can we make sure that these data are accessible by some, I don't know, some algorithms or some mechanisms 24/7? Yeah, 24/7. So all these are big data related. Okay. The current wireless technologies that we are using, which is Wi-Fi, majorly Wi-Fi, Bluetooth, and so on, they might not be sufficient after 10 years, around 10 years from now. Why is that? Because the number of the connected things or devices, IoT devices, is expected to be or to reach 125 billion devices in 2030. Yeah, can you imagine the number? So if you just think about it, how I explained just now to you from the application, one person can have a phone, a watch, maybe glasses, it will be soon, a laptop, what else? A tablet, maybe. All these actually things. So one person will have or will need actually many IPs, many they will have many many source of data to produce. So here you can see 125 billion actually is not really something little. We are only 7.2 billion. So you can divide and see how many devices per person. So anyway, so because of this number, huge number of devices, we will need actually better protocols, communication protocols than the existing ones. These are the first initiatives of IoT. The first one was this one, narrowband IoT. Then after that, LoRa and Sigfox, they came almost together, and they still actually in research, both of them. Yeah, this one kind of dying somehow, yeah. But LoRa and Sigfox is still now in research, even though there are some papers claim that these are already standards, but actually they are not. Anyway, if you want to read more about these protocols, you may read on this what they call it URL. Yeah, IoT standards. I can tell you from now, there is nothing called IoT standards. All of them, everyone is claiming to be the standard, so that grasp a lot of people to use it. So here, for example, application protocols. These are the 5 available ones, or the most famous ones, let's say. Each of them claim to be a standard, but actually the worldwide community does not recognize, until now, did not recognize any of them as standard. My applications that I ask my students to do, I ask them to do this, use it, MQTT, we call it. Yeah. Why? Because for me, I know some service which provide this protocol, so I ask them to use this. But actually, there are others beside it. Yeah. Which one will be the leader? We don't know until now, but soon should be revealed. There are other service discovery protocols as well. The previous ones will be obsolete soon. So there are new names coming soon, and they're still under research. You may read actually about these standards, okay, and this on this website. This website, in fact, it always updates the information. That's why I always follow the information from this website. But actually, there are tens of others. Yeah. Challenges. If you want to do research in IoT, search for challenges. These challenges of IoT, you can see how many, because IoT is still considered new, even though there are a lot of applications, but these applications lack for many things. For example, security. Yeah. Until now, there is no robust security scheme that protects my data. You saw that my data are being sent to the internet without any security, actually. So especially security is a huge gap, but others as well. Yeah, availability, reliability, and so on. So you may actually read survey papers about these, or you may just Google, for example, IoT availability challenges, and read about that gap only. Yeah. Another thing I want to leave you with to read is some keywords, those related to the current era of IoT technology. Definitely, I cannot cover all in one lecture. No one, I think, does. But anyway, I will leave you with these. So yeah, maybe you can study about each of them, at least definition, what it means, and so on. Like you see, for example, there is something called SOTA, Software on Air. What is that? Yeah. IPSO, Internet Protocol for Smart Project. What is that? So at least when you go to do your research, or you want to study maybe about IoT, you have some idea about these. And by the way, I don't know why I put it here in the middle, but it should be somewhere here written big. 5G. 5G is actually is the upcoming technology of connectivity. So I think this is really important keyword to study about, actually. So I will leave it for you. This you can Google it and search for it. Okay. From time to time, actually, I'm running some channel for technology. So that actually, from time to time, I give some videos. I show some videos. I share. Maybe I do the video, or I capture it from somewhere else. Yeah. After sure asking for their copyrights allowance. So the videos is not like 5 minutes, 10 minutes. Definitely, it's not. It's at least 1 hour or 45 minutes. So all the videos related to technology. So maybe you can follow there and you can watch the programs. So that's all what I wanted to share with you for today. I hope it was beneficial for you somehow, at least to spark some ideas about IoT and the new technology, so that I hope now you are eager to go and study after the lecture some more about the current technology. So I'm happy to answer any questions if there are any.
شكرا جزيلا دكتور، شكرا لهذه المحاضرة. حقيقة يعني هذا المجال، يعني أنا صحيح اختصاصي بالحراريات والطاقة يعني الأبحاث الحرارية. حقيقة هذا المجال شئنا أم أبينا هو اللي حيسود أو يطغي. بالحقيقة أنا عندي تعليق قبل ما أترك المجال لزملائي للسؤال. هو في الحقيقة هذا المجال تطبيقه راح يكون يعني انعكاسه إيجابي جدا على كل من يدرس الديب ليرنينج، لأنه الداتا سيت اللي هو دائما يبحث عنها راح تكون always available، وبدون ما يعني هذا هو أهم شيء، يعني راح يستفاد من عنده كل علوم الحاسبات بمختلف مجالاتها صراحة، يعني توفير ما يسمى بالداتا سيت.
I agree with you, Dr. Amjad. Actually, like this. You see, IoT job, as I mentioned just now, the job of IoT is to collect the data. So nowadays, when we do research and we search for data set to do our project, it might be very difficult to find the data. But I guess soon data will be very cheap. I think so.
And available، مو بس يعني not just cheap، cheap and available. يعني هو احنا حاليا سوينا محاضرة بالديب ليرنينج، محاضرتين تقريبا سويت من دكاترة من أمريكا وأيضا من استراليا. طلبوا السادة الحضور التدريسيين طلبوا لينك حتى يحصلون على الداتا سيت الافيلبل حتى يقدرون يشتغلون. إذا تعممت هذه الفكرة وقدروا كل الاختصاصات قدرت تعمل على أنه تنشئ داتا ترفع على الإنترنت، راح يكون هذا فشي كلش يعني متوفر. أنا أترك المجال لزملائي، راح أبتدي مع ست ابتسام رحيم. تفضلي.
السلام عليكم.
عليكم السلام ورحمة الله.
I would like to get many thanks for Dr. Maythem for this nice lecture. It really summarized everything about Internet of Things. But I would like to ask two questions. Where can I put the each computer according to what you say there for models for connectivity for Internet of Things? And the second point, there is, in fact, now many research towards version 2 Internet of Things that's related the problem of connectivity to solve it by 5G. So I don't know if there is latency now with devices to device is enough to make the data or the gather information to respond as fast accepted or different. And that's what I like to know about this topic. Thank you.
Okay, thank you, Dr. Sam. So just I want to clarify about the first question. You said the one in, let me just run it here. You said which model you asked for?
Edge computer, because you already classified the connectivity for modules for Internet of Things. But nowadays, to make the information available in fast way and make the response of devices as a latency parameter for each device is more, it will be helped by edge computer. This concept make information more requests available in server and to be handled direct to the user.
Okay. Okay. So if I understood your question correctly, so this one basically where each computer will be placed so that it can respond as fast as possible.
Exactly.
Right?
Yes. Yeah.
Okay. So that's why I said here that we need actually a new set of protocols. Let me show. Okay. First, these are the ones, the wireless protocols or technologies. Soon, we might not use Wi-Fi anymore for connecting the things. We will be using LoRa or Sigfox.
Yes.
In addition to that, you can see the routing protocols in between. All these are different than nowadays ones. Why is that? Exactly the point you touch, latency. Because if there are nowadays, if there are hundreds of devices communicating with each other, then the current protocols like ERGB or forgot like SRTP, for example, all these they will manage. They will be able to manage. But if instead of 100 devices, there are thousands of them, definitely the current protocols are not designed to manage such huge amounts of devices. This is why I mentioned that we need to new standards. Yeah. So yeah. So these standards, in fact, part of it, like some of it, as what I mentioned, are here, and the 5G is the big picture of these technologies. Yeah. Just like now, when I mentioned like IoT is the big picture for device communications, right? The new big picture for device connection, the connection, how the connecting will be, that's 5G. That's why the 5G that they claim to be super duper fast, but I don't know until now. They said that it will be like they claim some huge numbers. To be honest, different websites they claim different numbers, but I don't know if they can achieve it. But maybe they did. I'm not sure, to be honest with you. Yeah, but anyway, so answering your question, 5G protocols and the new protocols are in need actually to achieve the main purpose of IoT and reduce the latency, basically.
Yeah. Thank you.
Okay.
شكرا جزيلا. ننتقل إلى أستاذ رحيم. أستاذ رحيم عبد الصاحب.
نعم، السلام عليكم.
عليكم السلام، تفضل.
ممنون، شكرا جزيلا. Thank you for Dr. Maythem Abbas for this nice lecture. I think the attendees look for a specific subject from the lectures.
Sorry,
I have
really clear.
العفو أستاذ رحيم، الصوت شوية مو واضح جدا يعني. أكو المايك تقربه أو فشي.
Okay, thank you for Dr. Abbas for this lecture. Nice. I think the attendees look for a specific subject, and I have some questions about this lecture. The first question is the Internet of Things technology really used in the smart e-learning? This is the first question. And the second question, what are the trends and the future opportunities to invest in e-learning? And the third note is there are a real application used in the smart e-learning? Are there universities that use Internet of Things now? Please, you can name this universities if it's used in this universities, Dr. Abbas. Thank you.
Okay, thank you, Dr. Rahim. So actually, frankly speaking, the first question, I did not hear it very well, but the second, I hear it clear. Maybe you can just type it, Dr. Amjad, if you hear the question, maybe you can type the first question. But anyway, I will answer for the second one first, yeah? Okay. So Dr. Rahim asked me if there is some university have applied what's called as smart e-learning, and what's the name of the university, right? Frankly speaking, I do not know the name of the university, but I know it's a Chinese university, not the university, school. Sorry, school. This is school. In fact, they are using some kind of Euro device. They put on the head of the student, which has 3 sensors, one at the front and 2 behind. So that these devices will be placed on every student during the class time, and then the teacher will have the dashboard to check which student is focusing and which one is not focusing at that moment in the class. That's number one. Based on that focus and everything, the data, the history of the data will be sent to the mobile of the parents. I'm sure, I mean, they have to install some application, not really like SMS, no. But they have some application. They can monitor the performance of their children in terms of focusing. Yeah, not really as marks, but in terms of focusing. In addition to that, if we are talking about marks, then nowadays, actually, I think most of the Western universities, and definitely China, because China nowadays is the leading in IoT, they are using actually this performance live or live performance delivery or something like that. So every student will be able to follow up his attendance percentage, his maybe marks and so on. Yeah. One of the application I showed to you just now, I think it was the first example, university attendance system. This one actually real application in my two previous universities actually. Yeah. The students will be able to see how much percent they have attended the classes. The parents will be able to see that as well, just in case the son or the daughter will say, we are going to the university, but actually they are going to the cafeteria or something like that. Yeah, everything will be actually reported through IoT basically. Yeah, but again, nowadays, because the technology we are using nowadays is sufficient to manage these little number of things, of devices, like how many devices the students have. But in the near future, they want actually every person, whether he's student or non-student, maybe any alive creature, to have Internet of Things device somehow connected to him or her. Yeah. So I hope that answer your second question. Dr. Amjad, did you capture the first question?
I will ask Dr. Rahim to type it on the chat. So please, Dr. Rahim, if you can retype your question or type your question in the chat bar, so I can like take it, and also Dr. Maythem can have a look. أنتقل إلى ضاري، أستاذ ضاري علي. أستاذ ضاري تسمعني؟
نعم دكتور، نعم دكتور، نعم أسمعك واضح.
تفضل.
Thank you so much for this lecture, but I have one question if possible. As you know, Dr. Maythem, all the devices in IoT working with a platform. Someone, it's developed some private or some company developed some kind of platform for these devices. And the scalability, they say more than 1 million, you can work with this platform. In which way, as we are in the research part, we can test this kind of platform? It can be work with in the sufficient way. It can work with the 1 million or more than 1 million devices. Is there any way to test this kind of a platform? Thank you so much.
Okay, Dari, just ask this question, if I understood it correctly. Yeah? There is some kind of platform claiming that it can manage 100 up to 1 million or 100 million, you said?
Yeah,
1 million.
1 million or more than 1 million.
So about 1 million devices at the same time, right?
Yes, right. Yes, exactly.
Okay. May I know the name of the platform?
There are different platforms. They're from the private company. They say right now I don't have it exactly, but I read from the research. There is some kind of a private company, as you know, some kind of private company cannot provide you the code, or it cannot be open source. So when you say I have this platform and you need to check the scalability and the performance of these devices in the same time, how is there any way to check it? Is there any kind of, for example, virtual, or this is as a reality? It can be 1 million, can be working in the same time with in the platform.
Okay. According to my knowledge, if we have some platform or some entity that we don't have its own coding, and we don't know the details of it, then all we can do is to test it as black box. We implement black box testing on it. But to do so, it means you have to buy the license at least, and then you must have 1 million devices. But these 1 million devices, you can simulate them somehow using some networking, what they call it, some networking simulators. I'm not really sure about MATLAB, but it's the strongest anyway. But you can see there was Manet, for example, one of them. What was the other one? NS simulator. It's open source
NS3
simulator.
or NS3
yes.
or NS2.
Yeah. I think you can. Yeah, I think you can use that actually to simulate. But again, you are simulating the devices, the million devices, and they all have to generate data at the same time to a black box. That black box is basically the platform that you were talking about just now. And sure, you have to purchase the platform because you cannot really just use a trial. I don't think they will allow that anyway. And then see the results, whether it's really matching in terms of latency, in terms of error percentage, delivery rates. You have to do this basic networking analysis and see. Other than that, I cannot see any way because you don't have the code of it anyway. The other way, if you can have the code, then you may go manually and you go thoroughly the code and see the equations, and then you calculate by hand. If you are really investigating that platform, I mean, yeah, then you have to go and investigate manually, and you do the calculation by hand. Then you will see actually what's the result from that. But I can tell you one thing as well. Most of these companies, especially private companies, I mean, when I say private, I mean they are not they don't belong to the international community of internet or something. They claim anything. They might claim 1 million, but they don't tell you that 1 million, if they send 1 kilobyte, for example, 1 kilobyte or maybe 10 bytes at the same time, maybe. So if you run proper data, pictures or videos or something, then definitely they will not reach million. If there are, then they will be leading the internet world, actually. You get what I mean, right?
Yes, exactly. Yes. This is actually.
Yeah. Okay. I hope
so
then
thank you.
your question.
Thank you so much.
Okay, most welcome.
شكرا جزيلا. شكرا. إذا دكتور تقدر تطلع بالشات على سؤال أستاذ رحيم.
Okay, well, chat. Yeah. Okay.
أنا أقدر أقرأ لك إياه. Thanks Dr. Maythem for the nice lecture. I think the look for specific subject is the Internet of Things technology really used in smart e-learning. What are the trends and future opportunities to invest in e-learning? Is there a real application used in smart e-learning? Are there universities that use IoT? Can you name the universities? I think the last part of the questions you already answered.
Okay.
The first one.
The first one is the Internet of Things technology
really smart e-learning?
Smart e-learning. As I mentioned, yes, it is. Definitely, it is. You see, IoT does not come just like a phone and a computer, laptop, and they will start communicating. Definitely, it will come with sensors. And these sensors, there are tons of them. Whether you wanted to get a sensor for temperature, I mean, or sensor for humidity, or a sensor for the nerve, as I mentioned in the example just now, another for heartbeats, maybe position, or whatever. There are tons of them, right? So it depends on the application you are aiming for. You can choose the correct answer, the correct sensors, and then you program them somehow using some microcontroller thing, and then you can just use it. Yeah. So here, is it really used in IoT in e-learning? Definitely. And the example I just gave to you in terms of what they call it, China, the Chinese example. Yeah. What are the trends and future opportunities to invest in e-learning? Okay, this is difficult to say. This is difficult to answer. Okay, there are a lot actually of ideas, because what you are asking is what are the trends and future opportunities? When we say opportunities, we are talking about challenges. Ideas are there. Millions of ideas are there. You can see even science fiction movies, right? But are we able to do it? That's the main concern. So yes, trends and future opportunities definitely available, but how near that future is it nowadays future or really far future? Yeah, so I believe my personal view, I think with the current e-learning, it's already somehow saturated at its own level. But if we follow the steps of China in using more deep sensors like the neuro sensor and these things, then definitely there are a huge what they call it, huge opportunities, a huge list of opportunities actually. I can tell you one thing as well. Last 1 year and a half, I don't know, somehow I forgot how I got this interest in autistic people, those people who have autism. So how to teach them, how to teach these autistic people. After I visited some autism center, and then I saw how these students behave and how they learn, I found that every autistic person, even though they are staying in the same center, but each of them have different learning style. One of them, for example, learn by voice. You might see him playing here and there, but he is listening actually to what you are saying as a lecturer. The other might be looking at you, but he is thinking somewhere in China. Yeah, so this is the thing. How can we discover
zooming out of space?
Sorry?
They call it zooming out of space.
Yeah, something like that, yes. So the thing is, how can we measure or detect the rhythm of every student? So let's say this student, he learned by voice, this one by picture, this one by different thing. Currently, it's being done manually. but maybe in the near future, with the concept of the Chinese application just now using some neural-related sensors, we will be able to detect automatically. You know what I mean, Doctor? So definitely, there are a lot of opportunities and gaps in e-learning. So I hope this will help actually in autism as well. Definitely, I think it will. Yeah.
شكرا جزيلا دكتور.
Thanks.
شكرا جزيلا دكتور للتوضيح للأهمية الكبيرة لهذا الموضوع. احنا في شعبة البحث والتطوير حقيقة قبل يعني هي سبحان الله صارت مصادفة وهي محاضرة حضرتك. قبل ما نعد المحاضرة حضرتك ونتفق عليها، احنا تبنينا مشروع المستنبت الذكي بدعم من رئاسة الجامعة. تبنينا هاي الفكرة، والفكرة يعني بدنا نعمل عليها حاليا مع قسم السيطرة والنظم، وإن شاء الله راح نضيف إمكانيات متميزة لهذا المستنبت الذكي بحيث يدار بشكل كامل، والداتا مالته ترفع بشكل كامل على الإنترنت. ويعني إن شاء الله عندنا خطوات يكون انطلاقة في الجامعة التكنولوجية لمبادرة أتمتة لبعض المشاريع. فهي باي ذا واي سبحان الله يعني على النيات جت في محاضرة حضرتك. أنا أود أن أشكرك الشكر الجزيل، وأشكر الدكتور سليم خليفة اللي ساعدنا بتنظيم والتواصل مع حضرتك في إعداد هذه المحاضرة المتميزة. أشكر الجميع وأشكر كل من حضر. اسمحوا لي أن أنهي تسجيل محاضرة اليوم وأن